Today, on how it's made. Ice cream cones. We have the scoop on how they make them. Tent trailers. The story is about to unfold. Shoe polish. All shine and plenty of substance. And pliers. A gripping story. The ice cream cone is the original edible container. Invented over a century ago, it adds crunch to the melt-in-your-mouth taste of ice cream. And it's one container that doesn't end up in the waste stream. So you could also say it adds a bit of virtue to the guilty pleasure of the double scoop. The first ice cream cones were rolled waffles, and today's cones are simply modern versions of that. To make a waffle cone, they start with a lot of dark brown sugar. They add caramel coloring, along with some secret flavoring ingredients. They pipe water into the blender. It's ice cold to keep the batter from getting too sticky. A computer controls the flow of flour into the mix from a tank a floor above. They add vegetable oil as a giant beater mixes all the ingredients. The batter then flows out of the blender and into a refrigerated tank. At this point, the blend is the consistency of pancake batter, and an agitating blade keeps it that way. Next, nozzles deposit measured amounts of batter on a baking plate that looks like a moving waffle iron. Top plates flip down, and the baking plates roll through a gas-heated oven for a quick bake. The top plates lift up, revealing the cooked waffle patties. Automated arms help transfer the patties to rolling tools. The tools grab the patties and twist them into cones. The cones fall down a chute and ride an open elevator up and down to cool and harden. The waffle cones slide down another chute and move into lanes on a conveyor. Automated fingers adjust their position to prepare them to slide into paper jackets. A computer with a camera eye counts the cones and sends a message to a machine that stacks them in the right increments. Here, a technician activates a device that pushes on a ball inside a cone to test the cone's breaking point, proving this waffle cone can hold up to voracious snacking. Over in the sugar cone department, the baking plate system is designed differently. It makes patties that are fan-shaped and have a flat edge. This, combined with the type of batter used, means sugar cones are stronger than waffle cones, so they're a more popular choice for hard ice cream. Packers stack the cones in styrofoam trays. Then the packages travel through a curtain of high-density polyethylene film. A heated sealer finishes the wrapping job. An X-ray machine sends information about the contents to a computer that counts the cones and alerts the company to any problems. Next, automated arms pick up cartons and open them so the packs of cones can be inserted. Meanwhile, they mix up colorful batches of cake cone batter. Cake cones are less sugary and have a more cake-like texture, as the name implies. They pump the batter into upright molds. Cake cones are shaped very differently than waffle and sugar cones. They have flat rather than pointed bottoms. Metal cores plunge into the molds to complete the shape. This action also affects the texture of the cake cone, so it turns out flakier. They pass by a gauntlet of gas heaters to bake them. The cake cones then fall down a chute and head towards the packaging station. Unlike the other cones, they don't need a long cooling down period. They come out flaky and crisp. A mechanical arm picks up paper sleeves and drops them in front of the cones. It's all perfectly timed. These cones are now on their way to an ice cream stand near you, where, in their various shapes and sizes, they'll be used to dish up ice cream lickety-split. Tent trailers allow you to travel without reservations. Who needs a hotel if you can park the pop-up? Besides, you don't get fresh air and campfires at a hotel. Tent trailers have been around since the early part of the 20th century, and you could describe them as an overnight success. A tent trailer comes with all the modern conveniences, and that should make you a happy camper. To make one, they weld tubular steel components together. This establishes a solid framework for the tent trailer. Once it's painted, plumbed, and partially wired, they add wheels, bolting them into place. The water storage tank goes in next. Then they string aircraft-grade steel cables from corner posts to a central bar. This bar is called a wiffle tree. Cranking up the wiffle tree will cause the cables to lift the corner posts, raising the trailer's roof. They wheel the trailer to the next station, where they lower the vinyl-covered wooden floor onto the chassis and secure it with screws. Then they connect a cluster of wires to the wires already installed on the chassis to run things like kitchen appliances and stereos. They rivet the interior front wall to steel bulkheads and the trailer chassis. Then they thread wiring through the bulkheads to the trailer's side lights and then install the exterior panel. They slide the roadside panel over the lift posts and secure it. The curbside exterior panels come in two pieces to create a space for the trailer door. Corner molding completes this assembly. They move inside and install the framework for bench seating. They install the lower cabinetry for the kitchenette and then join it to the upper cabinet with a long metal hinge for easy pivoting. They insert the mini fridge in the lower cabinetry, and this folding kitchenette is done like dinner. This is the pull-out platform for one of the mattresses. They slide it into channels in the exterior walls. But there's a lot more work to do before anyone can take a nap. They stitch together pieces of water-resistant fabric to make the tent for the trailer. They sew 5 sections separately, then zip them together at an inspection station. Inspectors scrutinize every seam for flaws. None will be tolerated. Once the tent passes inspection, they fit it on the trailer one section at a time. Then the trailer is ready for the roof. To build the roof, they sandwich many materials together, and that takes a lot of industrial adhesive. They roll it onto these plywood slats. And these foam insulation boards also get a generous coating. They place the glued foam onto the roof's fiberglass outer skin. They position the wooden slats along the perimeter and add bands of metal for more reinforcement. The final layers are vinyl-coated plywood. It will be the ceiling of the trailer. A large roller compresses the glued layers together. After grooves and notches have been cut into the roof, they wire it and install 12-volt interior lights in the ceiling. They add trim to the roof's edges, along with a gasket to keep it watertight. They fold the roof's flaps in a tray-like configuration and cap the corners. They're now ready to raise the roof and install the tent. They insert it into grooves in the trailer ceiling using a pneumatic hammer. This tent trailer is now ready to pop up anywhere. It can accommodate a small family and is equipped to feed them outdoors or inside. It even comes with a screen door because who knows when adventure will come knocking. Mud and scuffing have long been the ruin of shoes and boots. In medieval times, they used wax to soften and waterproof leather footwear, but it didn't polish it. By the early 20th century, shoe polish as we know it was invented. It both gives shoes a shine and makes them last a long time. A great shoe shine takes a bit of polish and some elbow grease. A vigorous brushing can enhance the job and help transform your shoes from drab to fab. To make shoe polish, they start with mineral spirit solvent and different combinations of carnauba wax. They load the waxes into a wax melter and heat them to 127 degrees Celsius. They cook for 15 minutes while beaters blend it all together. This is dye fluid. This one is a deep black shade. In another tank, they add the dye fluid and waxes to the solvent blend. Agitators mix it for 3 minutes. Tin container bottoms tumble down a chute and up a magnetic conveyor belt. A worker flips the tins right side up, then pushes them onto another conveyor. It lines them up, and they're ready to be filled. Automated arms space the tins as they arrive at the filling head so they don't bunch up. The filling heads inject hot liquid shoe polish into the tins. The nozzles fill the tins with a precise amount, so there's no spillover. The polish now needs to cool down and solidify, so the tins travel through a cooling tunnel. When they emerge, the polish is a thick paste. Workers perform a breaking strength test to be sure the final product has the right consistency. The polish-filled tins now funnel onto a conveyor that merges with a feeder loaded with lids. The feeder lowers the lids onto the tins full of shoe polish. A compression wheel presses the lids in place with just the right amount of force. And this polish is now ready to shine. There's a different packaging system for liquid shoe polish. A blow molding machine forces hot air into plastic to form containers. Then the mechanized rack holding the containers rotates and places the newly formed bottles on another conveyor. It moves them under a flame which melts the rough edges. Revolving conveyors move under filling heads which pump liquid polish into them. Workers insert valves into applicators. Then this machine press fits the applicators onto the polish-filled containers. Using hydraulic pressure, another machine snaps clear domes onto the applicators. Rollers affix labels onto both sides of the bottles. The bottles then move through an inspection station. A mirror helps workers scrutinize the labeling job. A technician now takes a preliminary reading of the gloss on some leather. He applies some paste polish and rubs it in with a horsehair brush. He takes another reading, and the gloss on this leather has increased by a factor of 2, which means this polish passes muster, and it's ready to add luster to your footwear. Pliers date back to around 2000 BC. Ancient drawings show Greek gods using pliers at the forge. Today, forgers still make pliers, but these days they use automated tools to shape the metal. Pliers are standard equipment in the tool belts of electricians, plumbers, and mechanics. Pliers have 3 basic parts: handles, a rivet, and jaws. All the parts start out as steel rod that metal workers forge into shape. First, a powerful electric furnace heats the steel red hot in just a few seconds. Then a metal worker sets one sizzling rod at a time on a forming die. A massive die forger hammers the rod against the die with tons of force. It takes up to 4 strikes on separate impressions for the rod to acquire the die's shape. Then the forging is placed onto a press that trims off any excess steel. It takes 2 forged rods to make 1 pair of pliers. This pair will be for gripping, so the next step is to machine the teeth into the jaws. Workers set the plier halves into the broaching machine. Its tiny cutters, dozens of them, shave away steel under a shower of lubricant. When the cutters pull away, the jaw of each plier half now has a nice set of teeth. They must heat treat the steel to harden it, a process called ostempering. The plier halves travel through a gas-fired furnace for about 2 hours, at a temperature in excess of 800 degrees Celsius. Then they quench the steel in salt water to cool it rapidly and evenly. The teeth on these pliers will have to take a lot of abuse, so they get a laser heat treatment to make them even harder and more durable. Now the pliers are ready for assembly. For gripping pliers, a worker inserts a single-piece rivet and joins the 2 halves. He then sets the joint onto a machine that spins at high speed, generating force and friction to set the rivet. Cutting pliers are also held together with a rivet, but the setting process is different. The parts go into a press that applies both heat and pressure to secure the rivet firmly. Next, workers insert the cutting pliers between 2 stone grinding wheels. Again, lubricant prevents the steel from overheating as the wheels wear down the rivet until it lies flush with the plier surface. Next, the cutting pliers go into a gas oven for another 2 hours of heat treating, a process called mar tempering. When they come out, they cool in an oil solution, rather than the salt solution that cools the gripping pliers. Steel is a finicky material, so it's critical to manage the heat treating process meticulously, otherwise the metal will be substandard. After heat treating, the pliers go for a bath in a vat of rust inhibitor that helps protect the steel from corrosion and lubricates the riveted joints. A robotic arm runs 1 pair of pliers at a time against a grinding belt, polishing all surfaces except the handles for a sleek finish. Then a laser engraves the company logo and product number. Automated bars now lower hundreds of pliers handle deep into a tank containing liquid vinyl. No messy drips. Before dipping, the factory heats the pliers to help this coating stick to the steel. From there, the pliers go straight into an oven. The heat hardens the protective coating, cushioning the handles, so they're easier on the hands. Whatever their shape or size, pliers are a toolbox essential for anyone looking to ply their trade. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at www.howitismade.net.